Hi class, this is teacher Medza again. How are you? Today is another interesting subject. We are talking about Voltaic cells. Now this is the information or the knowledge that make some people really very rich. So understanding this information and apply as an entrepreneur, and they produce a product called battery, and this battery make life so easy for many people that everyone or every household in the world, except those even some primitive people, will have batteries in their homes. The least is to turn on their transistor radios, and especially today with everyone having a handphone, so the battery is everywhere, and people who manufacture this battery make a lot of money. So that's the job of the chemist, to do some research and pass the information, the research, to entrepreneurs to make this knowledge beneficial to mankind. So today we're going to talk about the Voltaic cells. Alright, let's proceed. If you look at this figure here, you will see a cell called the electrolytic cell. Now the reason why I'm showing you this is because I wanted to look at this diagram thoroughly and observe the settings, the items used, the electrodes used, and the electrical circuit, and the electrolytes, and so on. Observe them carefully. As you can see, the battery, the switch, the ammeter, the cathode, the anode, and the electrolytes. Because electrolytic cell is formed to convert electrical energy to chemical energy. That is the purpose. The purpose of the electrolytic cell is to convert electrical energy to chemical energy. And we use external circuit to pass electric current to electrode to induce chemical reactions. And the electrodes, the anodes and the cathode, and the anode is the positive charge electrode, while the cathode is a negative charge electrode. And this electrode can be of same material. It can be you can use copper, you can use same material, or you can even use different material, different metal, that is, it doesn't matter. And the flow of electrons is always from the anode to the cathode. And you look at the charges, the cathode will have a negative charge, the anode will have a positive charge. And the result in the electrolytic cell is the least reactive ions will be selectively discharged. So based on the electrochemical series, it doesn't matter whether you use the same types of electrode, different types of electrode, or copper. Whichever ions happens to be at the lowest position in the electrochemical series will be selectively discharged. Now that is the function of the electrolytic cell, which we have learned previously. But this is just to recap, so that you will see the difference when we talk about the Voltaic cell. Now look at this Voltaic cell. Can you look at the diagram? What is the difference? Well, they have cathode, they have their anode, they have all these electrodes rather, and now they have another equipment called a voltmeter. Whereas the electrolytic, we don't have a voltmeter, but here we have a voltmeter. So a voltaic cell, or simple voltaic cell, is a device to convert chemical energy to electrical energy. You see the difference? Whereas the electrolytic cell is to convert electrical energy into chemical energy, but voltaic cell is the opposite, that is to convert chemical energy to electrical energy. That's the difference. And chemical reaction that takes place inside the cell to cause the flow of electrons to produce electricity. That is what happens in a cell. And in this particular case, for the Voltaic cell, electrodes should be of different metals. It cannot be the same. So for the anode, a more reactive metal will be made as the negative terminal, while at the cathode, the less reactive metal is made the positive terminal. Now that is the rule. At the anode, the more reactive metal, while at the cathode, the less reactive metal is used as the electrode. And the flow of electrons, it is from the negative terminal to the positive terminal. So that is from the most reactive metal to the less reactive metal. So in this case, it will travel from the anode to the cathode. Although anode is having a negative charge, whereas the cathode is having a positive charge, the electron still flow from the anode to the cathode, whereas the electrolytic cell, although the electron still travel from the anode to the cathode, but then the anode is positive charge and the cathode is the negative charge. It is the opposite. The anode is a positive charge electrode, whereas the cathode will be the negative charge electrode. Now, when in Voltaic cell, it is the other way around. The anode will be the negative charge electrodes, whereas the cathode will be the positive charge electrode. So in this case, the most reactive ions are selectively discharged at the negative terminal, whereas the other electrolytic cell, it is the most the least reactive, but for Voltaic cell, it is the most reactive. See the difference? Alright. So here's an example of a magnesium copper cell. Now this is the common one. So Negative terminal is more reactive metal because it easily releases electron and form ions. So what do you suppose will be used at the terminal, negative terminal, which is the anode? Of course, it's magnesium, right? You know magnesium is very much higher than a copper cell in the electrochemical series. So the positive terminal should be the copper cell, should be the copper metal, because it is the less reactive metal. So positive ion receive electrons to be discharged. So this is the diagram, and you look, we have a magnesium terminal, anode at the negative terminal, whereas in the solution we have the copper 2 sulfate, and we have these copper ions. This is a correction, it's not dilute sulfuric acid, it is the copper 2 sulfuric acid. So this is a typo error again, right? So magnesium at higher position in electrochemical series than copper, and hence being more positive, release electrons more easily. That's what they do, you know. Then what happened? Magnesium anode dissolves slowly to form magnesium 2 plus ions. That is when you pass the electricity. You don't pass electricity, they produce electricity. So when magnesium anode dissolves to form magnesium 2 ions, it will move freely in the solution. And the half equation seen here is magnesium solid will yield magnesium 2 plus in aqueous after releasing 2 electrons. Then the most reactive ions are selectively discharged at the negative terminal. That's the result. Then the electrons from the circuit will travel to the copper metal, and the electrons will get donated or given to the copper 2 ions. So copper 2 ions will then be discharged. So copper 2 ions accept electrons from the copper metal and will be discharged because its position is lower than magnesium 2 plus ions in the electrochemical series. So the half equation is copper 2 ions when they receive 2 electrons will be discharged and form copper metal solid. So copper atom is formed and deposited at the positive terminal, and the copper electrode becomes bigger as time goes by. So that is the magnesium copper cell. This is normally used in our ordinary dry cell battery. Okay. So points to note is, the further the distance between the position of 2 metals in the electrochemical series, the bigger voltage is the cell. For example, magnesium copper cell produce higher voltage than zinc copper cell, because magnesium is higher than zinc. So magnesium copper combination will give a higher voltage compared to zinc copper combination cells. So we will learn that more in the electrochemical series later on. And the potential difference of the cell is the electromotive force that move electrons and can be measured by a voltmeter. So the force, the electromotive force that move electrons because of the potential difference of the cell, of the different metals used. So you don't need electricity to run this electron. It is the potential difference. When in electrolytic cell, you need electricity to pass through the electrodes to move the electrons. But in the Voltaic cell, it is the opposite. It is the potential difference that act as the electromotive force that moves the electrons. Alright, you can see the difference now. So another type of cell in the Voltaic series is the Daniell cell. Now if you look at this diagram, you'll see the green U-tube, not the U-tube, but this kind of U-tube, a different kind of U-tube, you know, where it is actually like a bridge joining two containers of electrolytes. So for this instance, we're going to use copper terminal and zinc terminal. So if you look at this diagram, copper is the positive charge electrode, whereas zinc will be the negative charge electrodes. Then we have this, what we call the salt bridge, and the salt bridge will allow ions to flow but prevent two electrolytes from mixing together. So you need a bridge to make this electron flow. So they use what we call U-tube to act as a salt bridge. So the solution is the solution used is copper 2 sulfate solution and zinc sulfate solution. Now there are two different solutions here. So when two different solutions, you have two different types of ions. So we cannot mix them. Now we have to separate them. But the ions will flow because of the electromotive force. So zinc metal will release its electron because it is more reactive, and then through the negative terminal, and zinc metal dissolve and becomes thinner. So it will what happen is the zinc as a solid metal will yield zinc two positive ions in aqueous after releasing two electrons. Then at the copper side, the other electrode, copper being less reactive, will accept electrons from the positive terminal, and then copper becomes thicker when layers of copper are deposited at the copper metal after a period of time, that is. So now from the copper 2 ions in aqueous, when after receiving two electrons, will transform and becomes copper metal in solid. So when the electrons start flowing, you know, if you put a bulb, the bulb will light up. Alright. So concentration of copper 2 sulfate decreases and the blue solution becomes paler, because the ions are becoming into metals, so the solution is becoming paler and paler. And the overall equation you will see is zinc as solid plus copper 2 ions in aqueous, through the salt bridge will yield zinc ions aqueous and produce plus copper metal in solid. So zinc from solid will become ions, and copper from ions become solid. That is all about it. And they need a bridge to make them move. And another way is this Daniel cell to do its function. Besides salt bridge, porous pot can be used. So this porous pot acts the same like the bridge. It will keep all the solution in contact, but allow electrons to travel. It perform the same function. So look at the anode, which is of zinc rod, and the cathode is copper rod. Now the porous pot will contain zinc sulfate solution, whereas in the other part of the beaker the copper 2 sulfate solution is placed. So the porous pot which has fine pores will prevent aqueous solution from mixing, but allows ions such as NaCl, KCl, H2SO4 to pass through. So now we come to the dry cell. So this is a simple dry cell which we call the battery, where you use for your radios, torchlights, where they use freely. Everybody have battery in their homes. So this is the cut up of the battery to see what's inside. So of course you have at the top the brass cap. Then right in the middle we have the carbon rod, which act as the positive terminal, and then we have the zinc case at the bottom, which acts as the negative terminal. Then we have the porous container, and then we will see that this product uses besides the carbon rod also powdered carbon and magnesium oxide. Now of course there must be a reason for doing this. So the powdered carbon is a good electrical conductor which will help reduce the resistance in the cell. At the same time, it will increase the surface area of the carbon rod. Then what about the magnesium? The job of magnesium is to oxidize the hydrogen gas that is produced. Now this is to reduce the cell polarization when hydrogen gas produced surrounds the carbon rod. Now as you know, hydrogen is very volatile. If you allow them on their own without any guard, they may create a bomb. It may explode. The moment you switch on your torchlight, boom, it goes. So this is the job of the magnesium, to hold on to the hydrogen ions so that they behave themselves and they don't act aggressively. And that's the reason when you have finished using this battery, you don't just throw into fire or anything like that. It definitely will explode. So you have to dispose them carefully. So at the carbon rod, they will take up all the electrons. So in this case, 2 NH4 positive in aqueous will receive 2 electrons and yield 2 NH3 in gas form, and then plus 2 hydrogen gas. You look at the hydrogen gases form. That's the reason why we need the magnesium to guard this hydrogen gas, so that they behave themselves, right? Whereas at the zinc case, the negative terminal will release electrons. So from the zinc solid, you will produce zinc ions in aqueous when they releases the 2 electrons. So zinc and copper, which one is stronger? Which is more reactive? The zinc is more reactive. So that is how the motive force will take place to make the electrons flow. So the overall equation shows here as zinc in solid plus 2 NH4 plus in aqueous will yield 2 NH3 in gas form, and plus 2 H2 in gas form, plus zinc ion, zinc 2 plus. So they use the electrolyte, they use ammonium chloride base. So this is what the ordinary battery that you take for granted looks like. See, a lot of ideas have been put into this, and effort and design to make life comfortable for you. So it is worth paying for the battery. Alright, so whenever your battery is finished, so don't just throw that into fire or anything like that, right? Now this is another battery. This is in your mother's car, which we call the lead acid accumulator. It's the same thing. So it is produce a powerful battery to make your vehicle travel from London to Sydney, or from New York to Los Angeles, or from Arau right to Johor Bahru or to Singapore, or from Kota Kinabalu to Kuching. Hopefully from Kuching will travel up to Tawau when the Pan Borneo highway is ready, and you need this battery to make your vehicle function effectively. Without this, your vehicle will not function, your radio will not play, your aircon will not be on, and your engine will stall. So this is a very important equipment called the lead acid accumulator. And you know how many millions, or if not billions of cars, and you know how many billions of these batteries, and you know how much these batteries cost? Then you know people who do this battery make billions and billions and billions of dollars or ringgit. So the electrolyte used is the dilute sulfuric acid, H2SO4, and we use the lead plate coated with lead oxide as the positive terminal, and they will react with the H plus ions in the H2SO4. So upon receiving electrons, so PbO2, that is plumbum, O2 plus 4H, 4 hydrogen, after accepting 2 electrons, will yield that 2 ions and plus 2 H2Os. And the other is at the negative terminal is a lead plate, which act as the negative terminal, and they donate electrons. They give electrons. So from the lead, when they give up their electrons, they will yield the plumbum to I beg your pardon, lead to ions. Well, plumbum, then they call lead. Well, anyway, it's easy to say lead, so we just use lead then. And the overall equation will be like this: Pb solid plus PbO2 also solid. Then after giving off 4 electrons, not 4 electrons, yes, Pb solid plus PbO2 solid plus 4H plus aqueous, then plus 2 SO4, 2 negative aqueous, will yield 2 PbSO4 aqueous and 2 H2O liquid. Sometimes when you look all over this, you get confused yourself, so just be careful, just look thoroughly. So the overall equation is Pb lead solid plus Pb oxide 2 solid. There are 2 metals here, the lead coated positive terminal and the lead plate negative terminal, and plus 4 hydrogen, when H accept the electrons, 4 of them in aqueous, plus 2 SO4, 2 negatives in aqueous, will yield the 2 PbSO4 aqueous and 2 H2O liquid. That is how complicated this reaction is. That's why it is expensive, but it's just a matter of being conscious and look and understand, then it will never be a problem. So you look at the 2 plates, the green and the brown ones, the PbS and PbO2s, and then plus 4 hydrogen aqueous plus 2 SO4, 2 negatives in aqueous, will yield 2 PbSO4 aqueous plus 2 H2O molecules liquid. That's it. And the sulfuric acid is used up, but water is produced. So you have the 2 H2Os, and the SO4s are now been converted to SO4. The sulfuric acid becomes more dilute and its density decreases. Then lead to sulfate produced is insoluble, exists as a white precipitate. So if you look at your parent's battery, you look at the terminal, you will see some white stuff. So that is what we call the white precipitate, which is actually lead to sulfate. And the accumulator can be recharged by passing electric current in the opposite direction to renew the cells. So this is what the lead acid accumulator is all about. So guys, we have gone through the electrolytic cell, we have gone through the voltaic cell and types of voltaic cells. So all you need to do is you refer to your textbook. You can see the benefits, the advantages and disadvantages of the types of battery that you use. Of course, some are light, easy to use and cheap. Some are, quite expensive. Some are heavy and whatnot, and the rest. So, the battery is manufactured for its purpose, especially using the mercury battery, the one in the calculator, the small round type, or in your watch. So that is mercury. They use mercury. So they are very light but very long lasting, and of course it is expensive. 15 ringgit, 12 ringgit a battery, compared to some other battery, 2-3 ringgit from the China, the cheapest ones, and of course the like others. But then for some of the equipment you use often, like cameras and all that, you need rechargeable batteries. So the cadmium battery will be useful. So if you refer to your textbook, you may find all the advantages and disadvantages of all the voltaic cells. So before we close, as a final check, let's compare the voltaic cells and the electrolytic cells. So you can see for yourself the electrolytic cell. This is how it looks. They use the external circuit with the power source, the battery, with a switch and meter, whereas the voltaic, they only have a voltmeter to measure the current. They don't produce the current, but they measure the current. Haha, fantastic. So the difference between electrolytic cell and the voltaic cell. Let's look at the difference. Conversion of energy. Well, electrolytic cell will use electrical energy to produce chemical energy, right? Whereas the voltaic cell will use chemical energy to produce electrical energy. It's the opposite, totally opposite. What about the cathode? Well, for the electrolytic cell, the negative terminal is always the cathode, whereas for the voltaic cell, the cathode got to be the positive terminal. You can see the difference is only opposite, so does at the anode. Look at the anode now. So for the electrolytic cell, the positive terminal is the anode, whereas for the voltaic cell, the negative terminal is the anode. What about the flow of electrons? So for the electrolytic cell, it will be from positive terminal to negative terminal. The flow of electron is from the positive terminal to the negative terminal, whereas for the voltaic cell, it is from the negative terminal to the positive terminal. It's the opposite, always the opposite. So you get one, you'll get the other. So when you are asked in your exam to show the difference, I'm pretty sure you can show the difference, right? So type of electrodes, so you can use carbons. For the electrolytic cell, you can use the same or two different metals. It doesn't matter, you can use the same metal or two different metals. because only the electrochemical series will determine which ion will be selectively discharged. But for the Voltaic cell, you definitely have to use two different types of metals. So depending on what voltage you require, you want a higher voltage, you use the zinc, you use the magnesium copper combination, or if you want a lower voltage, you can use the zinc copper combination. But you need to have two different metals, because it is the potential difference that move the electrons, right? It's not electricity, but the potential difference. So for the negative terminal, cations receive electrons from the cathode, right? You remember? At the cations, the cathode having negative charge will receive the cations which are positive charge ions, right? And at the negative terminal, electrons are released at the anode. So when you look at the difference now, so it's just the opposite. If cation receive electrons from the cathode, then at the negative terminal, at the anode, electrons are released for the Voltaic cells. Just the difference, right? And then for the electrolytic cells, at the positive terminal, anions release electrons to the anode, whereas at the in the Voltaic cell, at the positive terminal, electrons are received by the cathode. See, this is the difference, which is quite obvious. So if you know one thing about the electrolytic cell, then you can know the the opposite of the Voltaic cell, just the opposite. Yeah. All right. So next lesson we will delve a little bit deeper into the electrochemical series, and I hope that lesson will make you understand the Voltaic cell, or the electromotive force, which is the potential difference that move these electrons. And I hope this lesson has opened up your mind a bit to understand the difference between electrolytic cell and the Voltaic cell, and understand the batteries. So guys, repeat this lesson over and over again if you are not very sure. Until we meet again next week, this is Teacher Medza saying bye, and thank you for your time.